Last lesson, we found the derivative of x raised to n using first principles, and that rule is called the power rule. The power rule. If f of x is x raised to n, because it is like an exponential in the power form x raised to n. So if f of x is x to the power of n, its derivative f dash of x will be n into x raised to n minus 1. The power n comes down n times x to the power of n minus 1. So for example, if it is x raised to 7, so n is 7 there, so f dash of x would be 7 times x raised to 7 minus 1, which is 6. So 7 x raised to 6 would be the answer. So that's called the power rule. If f of x is x raised to n, its derivative will be n into x raised to n minus 1. We are going to look at some special cases of it. If you refer to the data booklet, you would only see this one formula. Anything else comes on this in the algebraic format, in the power form. You need to express it first in the form x raised to n and then differentiate. But what I am going to discuss here is, I will discuss 3 or 4 special cases under this rule, of which the first one is f of x is equal to x. When I say x, the power of x is 1. So this is x raised to 1. So it's like x raised to n if I read it as x raised to 1. So I can differentiate it, and when I differentiate it, the answer would be 1 into n into 1 into, so your n is actually 1 here, x raised to 1. So 1 into x raised to 1 minus 1, which would give me 0 there. But x raised to 0 is 1, so the answer turns out to be 1. So that's my first result. If you have x as the function, its derivative would be 1. So instead of doing it this way, it would be good if you know the result directly. I'm going to look at another special function. F of x is equal to 1 over x. I can always shift this to the numerator and make it like x raised to minus 1, because 1 by x raised to 1 it is. X means x raised to 1. When I shift it to the numerator, it becomes x raised to minus 1. And then it looks like x raised to n. And the derivative would be n into x raised to n minus 1. So here n is minus 1. So when I differentiate, I will get f dash of x is equal to minus 1, n into minus 1 into x raised to n minus 1. Minus 1 minus 1, which is minus 2. But this x raised to minus 2, I can write it as 1 over x squared. With positive power, I can write it in the denominator. So this is going to give me minus 1 by x square. So whenever you get a question of this type, 1 by x, I can do like this by shifting it to the numerator as x raised to minus 1 and do it yourself, referring to the basic formula, the power rule which you have in your data booklet, but nothing like knowing it by heart like this. 1 by x derivative minus 1 by x square. You save a lot of time, and it's also useful in a later stage. So derivative of 1 by x is 1 over minus 1 by x square. So two special results we learn now. If the function is x, derivative is 1. If the function is 1 by x, the derivative would be minus 1 by x square. You can also work it out yourself. This is f of x is equal to k. K stands for any constant there. For example, f of x is equal to 7. F of x is equal to 8 without any variable along with it is called a constant term. So f of x is equal to k. So what I am going to do is, I am going to read this k as k into 1. And that 1 I will write it using the variable x as x to the power of 0, because x to the power of 0 is 1. So k into 1 is k. So this is k can be written as k times x to the power of 0, which is 1. So k into 1 is k, it's back to k itself. But now I am in a position to apply this power rule. This k here now is called a coefficient, because it is followed by a variable part. So coefficient k, when I differentiate, k would stay there, and x raised to 0 according to this rule would be 0 into x raised to 0 minus 1. But 0 into anything would make it 0. So the result is that f of x, if f of x is a constant, its derivative would be 0. So if f of x is 7, derivative is 0. If f of x is 10, derivative will be 0. Derivative of any constant is directly 0. Another one, f of x is equal to root x. Again, it should be in the power form. So root x I'll write as x raised to n, x to the power of half. And now I can apply this rule, n into x raised to n minus 1. So the derivative of this would be half into f dash of x would be half into x raised to half minus 1, which I wrote as negative half. Half minus 1 is negative half. But x raised to negative half will go to the denominator as x raised to positive half, and x raised to half will be root x. So my answer is 1 by 2 root x. Again, if you learn it by heart, it's good for you because you can save these steps. Root x derivative is 1 over 2 root x. So look at these results. So x raised to n derivative is n into x raised to n minus 1. Based on that, derivative of x is 1, derivative of 1 by x is minus 1 by x square, derivative of any constant is 0, derivative of root x is 1 by 2 root x. I am going to list those results one more time. If f of x is x raised to n, its derivative will be n into x raised to n minus 1. If f of x is x, its derivative would be 1. If f of x is equal to a constant, its derivative would be 0. If f of x is 1 by x, its derivative would be minus 1 by x square. And finally, if f of x is root x, its derivative would be 1 by 2 root x. We're going to do the exercise questions now. This is exercise 12a from your book. The question says find f dash of x given that f of x is, then there are sub questions. A, f of x is x cubed, and I'm going to differentiate it. When I differentiate it, I identify the type. This is in the x raised to n format, so I apply the power rule of differentiation. Therefore, x raised to n derivative would be n into x raised to n minus 1, I know, so I apply the rule. N is 3 here, so f dash of x would be 3 times x raised to 3 minus 1, which is going to be 3 times x squared. That's a question for you to try on your own. And C, f of x is equal to x raised to 11. So that's your question. F of x is equal to x raised to 11, which looks like x raised to n again, and x raised to n would be n times x raised to n minus 1. So f dash of x would be n is 11, 11 times x raised to 11 minus 1. So that's going to be 11 times x raised to 10. Next question is for homework. You will try that yourself. But one thing what you need to remember here is that 6 is not treated as a constant. 6 is a coefficient there. So 6 would stay there and derivative of x would be 1. So 6 into 1, 6 will be the answer. F of x is 2x cubed. When I try to differentiate this again, 2 is not treated as a constant. It's a coefficient because it is followed by a variable part. So f dash of x would be 2 into the coefficient always stays there. And then we will look at x cubed. Its derivative is 3x square. 2 3s are 6 there, so you'll get it as 6x squared. The next question, f of x is equal to 7x squared. You will do that for homework. F of x is equal to 3x raised to 5. So 3 is coefficient, so when I differentiate, f dash of x would be 3, the coefficient would stay there, and derivative of x raised to 5 would be 5 times x raised to 5 minus 1, 4. So 5 3s are 15, so 15 x raised to 4. For you to try on your own, and then we move on to the next question. F of x is equal to 5x minus 2. So there are two terms, and differentiation is distributive over addition and subtraction. So if there are two terms being added, you differentiate the two terms separately, individually. So f dash of x would be 5 is a coefficient, so it stays there, into derivative of x is 1. So 5 into 1 minus 2 is a constant because it is not followed by a variable part, so its derivative is 0. So you get just 5 as your answer. You have a question there for you to try. You can pause the video and do it yourself. The next one, f of x is equal to x square plus x. Again, there are two terms and differentiation is distributive over addition. So, I will differentiate the first term plus I differentiate the second term. So, f dash of x would be x square derivative is 2x plus derivative of x is 1. That's for you to try, and we look at the next question. F of x is equal to 2x square plus x minus 1. So, here there are three terms. So, I will differentiate the first term plus I differentiate the second term plus I differentiate the third term. So, f dash of x would be 2 times x square. X square derivative is 2x. So, 2 coefficient stays there and x square became 2x plus the next term x would become 1 and the last term minus 1 will become 0. So, your answer is 4x plus 1. That's for you. And we look at f of x is equal to x cubed minus 4x square plus 6x. So, if you look at this question, there are three terms. So, I will differentiate them term by term. So, f dash of x would be the first term x cubed derivative is 3x squared minus this 4 is a coefficient which will stay there and x square derivative would be 2x and the last term is plus 6x derivative would be just 6 into 1 which is 6 into 1. So, 6. Now, of course, we simplify it a bit. So, 3x square stays the same, 4 2s are 8. So, 8x plus 6. That's for you. The next one, f of x is equal to 1 by 5x cubed minus 7 by 2x squared minus 2. So, there are three terms. So, 1 by 5 is the coefficient there. So, when I differentiate 1 by 5 will stay there and derivative of x cubed is 3x squared minus 7 by 2 is a coefficient which will stay there. Derivative of x squared is 2x and the last term is a constant. So, that's going to be 0. A little bit of simplification, this 7 by 2 into 2, 7 by 2 into 2. So, 2 and by 2 will get cancelled. So, that will reduce to 7x. The rest is your answer. So, the next question, question number 2, it says differentiate with respect to x. And your first question, f of x is 1 by x square. And this question doesn't look like x raised to n. So, I need to make it into x raised to n, the power form. So, 1 by x square, I will shift it up. So, that will be x raised to minus 2 and then x raised to n pattern and x raised to n derivative is n into x raised to n minus 1. So, minus 2 into x raised to minus 2 minus 1. So, the derivative f dash of x would be minus 2 into x raised to minus 2 minus 1. So, that is going to be minus 3, but I can put it in the denominator as with positive power. That's for you to try. And the next one, f of x is equal to 3 by x. Okay, this I can shift it up as x raised to minus 1 and do it, but I am not going to do that. We saw a special result. If you read your question like 3 times 1 by x, I know the derivative of 1 by x already. 1 by x derivative is minus 1 by x square. So, derivative of this function f dash of x would be 3 is the coefficient which would stay there and derivative of 1 by x is minus 1 by x square. So, that's going to give me minus 3 by x square. And the next question for you to try. And the next one, f of x is minus 7 by x raised to 4. Again, this is not in the x raised to n format. So, I need to shift this x raised to 4 to the numerator. So, it will be negative 7 into x raised to negative 4. 1 by x raised to 4 can be written as x raised to negative 4. Now, I will differentiate it, and when I differentiate it, negative 7 is going to be a coefficient and so it would stay there. Negative 7 coefficient would stay there. And x raised to negative 4 derivative would be n into x raised to n minus 1. So, that will be negative 4 into x raised to negative 4 minus 1. Of course, now these two numbers will multiply. So, that is going to be 28 and x raised to negative 5 goes to the denominator. That is your question. And then we look at this question. F of x is equal to x squared minus 6 by x. So there are two terms when I differentiate. X square is 2x, I know. This I need to rewrite. I will read it as negative 6 into 1 over x because I know the derivative of 1 over x. So I'm going to differentiate it now. Therefore, f dash of x would be x square is 2x minus 6 into, minus 6 stays there because it's the coefficient, and derivative of 1 by x is minus 1 by x square. So 2x, and then minus into minus is plus, so 6 by x square. 2x plus 6 by x square. We practice some more questions. F of x is equal to 2 by x square plus 9 by x raised to 4. So here there are two terms, and in both the terms I got variables in the denominator. If it is 1 over x, it's fine for me. I can write 1 over x derivative as minus 1 by x square. But if it is not 1 over x, it is 1 over x square here and 1 over x raised to 4 in the second term. So I need to shift them to the numerator. So 2 times 1 over x square is written as x raised to negative 2 plus 9 times 1 over x raised to 4 is written as x raised to negative 4. And then we differentiate. So f dash of x is equal to 2 into x raised to n derivative is n into x raised to n minus 1. So the derivative of x raised to minus 2 is minus 2 into x raised to minus 2 minus 1, which is minus 3, plus 9 into x raised to minus 4 derivative is minus 4 into x raised to minus 4 minus 1, which is minus 5. Little bit of simplification. The negative 4 and x raised to negative 3 goes to the denominator as x cubed. Here 9 into negative 4 would be minus 36, and x raised to negative 5 goes to the denominator. And the next one, f of x is equal to 5 minus 8 by x squared plus 4 by x cubed. Again, variables are in the denominator, so I need to shift them up. So 5 minus 8x raised to negative 2 plus 4x raised to negative 3. And so we differentiate. So f dash of x would be 5 would become 0. Then I have this minus 8 to be written as it is, and x raised to negative 2. This negative 8 is a coefficient, so it stays. Like one more time, this 5 is a constant, so that becomes 0 because it is not followed by any variable. It doesn't have any variable with that. So 5 is a constant, so its derivative is 0. Minus 8 is a coefficient, it stays there, and the derivative of x raised to negative 2 is n into x raised to n minus 1. Negative 2 into x raised to negative 2 minus 1, which is negative 3. Plus 4 into x raised to negative 3 is negative 3 into x raised to negative 3 minus 1, which is negative 4. We do a little bit of simplification there. That's 16 there, and x raised to negative 3 goes to the denominator. 4 into negative 3 is 12 there, and x raised to negative 4 goes to the denominator. F of x is equal to 4x minus 1 over 4x. Okay, 4x I know how to differentiate. So 4 into 1 it would be. This I want to rewrite it. I will rewrite it as minus 1 by 4 into 1 by x, because 1 by x is minus 1 over x square. So that's the reason why I rewrite it. So 4x I am leaving it. Minus 1 over 4x I will write as minus 1 by 4 times 1 by x. Minus 1 over 4x is minus 1 by 4 times 1 by x. And so when I differentiate, f dash of x would be derivative of 4x is 4 into 1 minus 1 by 4 into derivative of 1 by x is minus 1 by x square. Now when you simplify this, minus into minus will be plus. So your answer is 4 plus 1 by 4x square. F of x is equal to 2x minus y by x square. So here what happens is, this is division. I can't differentiate this term by term. Differentiation is not distributive over multiplication and division. So if you get either multiplication or division, you need to get rid of that form. Of course, we will learn a rule for multiplication later on. At the moment we haven't seen it, or at the moment we haven't learned a division rule, so we need to get rid of that division form. So there are two ways of doing it. One is shift this x square up and make it x raised to minus 2 and multiply it in, or you divide them separately. One of the two. I'm going to divide them separately. Like I divide the first term by x square and minus 5 by x square. Divide both the terms separately by x square. An alternate method would have been like shift this up as x raised to minus 2 and multiply inside. Here I just divided them separately. And when you simplify, this is 2 into 1x cancels, so 1 by x, so 2 into 1 by x, and minus 5 and x square goes up as x raised to minus 2. Now it's your normal question, so we differentiate. So f dash of x would be 2 into 1 by x derivative is minus 1 by x square. Minus 5 is coefficient which would stay there, and x raised to minus 2 is minus 2 into x raised to minus 2 minus 1, which is written as minus 3. Of course, we simplify that, and so you get 10 by x cubed. And that question is for you to try, and what you would do is the same thing. You will divide them separately. There are two ways. You could divide separately, or you could even take it up and then open the bracket. Okay, divide separately means it would be like x cubed by x plus 4 by x, and then you can simplify it further and try it. Yeah, so that's for you to try on your own.